In Chapter 8, we're going to start talking about transformations. In Section 8.1, one of those transformations is a translation. So on page 495, let's read the gray box together. It says that you can change the position of a geometric figure so that the angle measures and the distance between any 2 points of the figure stay the same. Basically, you have two congruent figures. A transformation of a geometric figure is a function or mapping that results in the change in the position, shape, or size of the figure. When you play dominoes, you often move dominoes by flipping them, sliding them, and turning them. Each move is a type of transformation. The diagram below illustrates some basic transformations that you will study, and it shows flipping, sliding, and turning. In a transformation, the original figure is a preimage. There's a vocab word. The resulting figure is the image. Some transformations, like those shown by dominoes, preserve distance and angle measures. To preserve distance means that the distance between any 2 points of the image is the same as the distance between the corresponding points of the preimage. Basically, the sides stay the same size. To preserve angles means that the angles of the image and the preimage are both the same. A transformation where everything is the same and the distance and angle measurements are preserved is called a rigid motion. So on page 496, we're going to do the entire page. Problem 1, we're going to identify whether or not it's a rigid motion. If we look at the Got It problem A, it asks, does the transformation appear to be a rigid motion? A would be yes. All the angles and sides are still the same because the two shapes are congruent. B would also be yes. All sides and shapes and angles are congruent. Number 1, yes. However, number 2 would be no because they're different sizes. Since the sizes have changed, it is not the same figure. On the top of page 497, it talks about a transformation maps every point of a figure onto its image and may be described with arrow notation. Prime notation is sometimes used to identify image points. In the diagram below, K prime is the image of K. So your normal shape in that figure is triangle JKQ. If we do a transformation with it, in that case it's been reflected, the new points are now J prime, K prime, and Q prime, and that's called the image. Notice that you list corresponding points of the preimage and image in the same order. So in problem 2, it says, under the Got It, in the diagram, triangle NID is going to be mapped into the image triangle SUP. What are the images of angle I and point D? Well, angle I would turn into angle U, and point D would turn into point P. Now, on B it says, what are pairs of corresponding sides? Well, the corresponding sides, for example, would be segment NI and segment SU, segment UP, segment ID, segment DN, segment PS. Let's do number 3 together under the practice. So in number 3, A says choose an angle or point from the preimage and name its image. So the preimage is just your normal R, T, P, just normal points. Your image is going to be the prime, P prime, R prime, T prime, and so on. So we just want to name any angle from the preimage and name its image. So we could, for example, say angle R is going to become angle R prime. We could also say angle T is going to become angle T prime. Now part B says list all pairs of corresponding sides. So, corresponding sides. We have segment RP, and segment R prime P prime are corresponding. Segment PT and segment P prime T prime are also corresponding. Segment RT and segment R prime T prime are also corresponding. Now we're going to go on to our key concept. Turn to page 498. Page 498, this is your big vocab word of this section. A translation is a transformation that maps all points of a figure the same distance in the same direction. Basically, you guys have been taught this is a slide. It's either going to go right, left, up, or down. When you write the translation that maps triangle ABC onto triangle A prime, B prime, C prime, as, and then it shows a T, that means translation. Triangle ABC equals triangle A prime, B prime, C prime. A translation is a rigid motion with the following properties. And then it shows all your properties about corresponding sides, what they mean, and you'll notice that it shows that the sides are both equal on the pre-image and the image, and so are the angles. So read the gray region together on your own. You'll notice that it says this, T 4, -2, A, B, C, D. What that means is this is your x value. Your x value goes left or right. So this would mean you would translate your figure right 4 spaces. And this tells you up or down, because that's your y-axis. So this would be down, since it's negative, 2 spaces. So in problem 3, it says, what are the vertices of this translation? And then copy the triangle ABC and graph its image. So all I want you to do is graph its image. So that means we're translating it. So we're translating it. This would be right 1. And this would be down 4. So right 1. So I'm going to move everyone right 1, down 4. So I'm going to start with A. Right 1, down 4. 1, 2, 3, 4. Right 1, 1, 2, 3, 4. Right 1, 1, 2, 3, 4. So then this would become A prime, B prime, and C prime. And we need to write the coordinates. So we would say A prime is the coordinate -1, -2. B prime would be 2, -3. And C prime would be 1, -5. Now part B says, draw those 3 sides. What relationships exist among them? Now, all that means is that the relationship between them, they're going to be rigid motions. They're all the same. So because the rigid motions preserve the distance and the slope of each segment, they're exactly the same thing. Now, I'm not going to have you find the slope of each segment, but you should realize that if you just slide something, it's a rigid motion. Nothing changes. These 2 shapes are going to be absolutely congruent. The angles are all going to be the same, and so are the sides. In problem 4, we're now going to be given the translation, and we're going to have to write a rule to describe it. So if you look at the got it problem, it says that the translation of image triangle LMN, which they give you in the drawing, is triangle L prime, M prime, N prime, with L prime being at 1, -2, M prime being at 3, -4, and N prime at 6, -2. So here's the picture it gives you. This is the pre-image. Now if we draw the picture, it says L prime is at 1, -2. M prime is at 3, negative 4. And N prime is at 6, negative 2. All it's asking you is, and I think I drew that wrong here, 3, negative 4. I drew M wrong, so let me fix that. There we go. So when you draw this, you can just look at it and see what happened. How many to the right and how many to the left. So you know that this shape went, if we count, I'm going to do this in black. Let's do green. So let's say N. N went how many spaces right? 1, 2, 3, 4, 5, 6, 7, down 1. So each one went right, 1, 2, 3, 4, 5, 6, 7, down 1. So right and then down. Right and then down. So each one went right 7, down 1. So your rule would be a translation, and we went right 7, down 1. And that transformation was of triangle L, M, N. The other way that you could have done this is by just taking one of the points. For example, you could have taken point L. Point L was negative 6, negative 1. L prime is 1, negative 2. All you could have done is realize that, what's the difference here? Subtract them. So if we subtract my x's, that gives me a distance of 7. Subtract my y's, that gives me negative 2 minus negative 1, which is negative 2 plus 1. So that means my x value went right 7, and my y value went down 1. So you can either graph them and just see how far up, down, left, right it went, or you can do it mathematically. So if we look at number 7 on the top of page 500, just look at it yourself and tell me that what happens from the blue figure to the red figure. Well, where did it go? On number 7, translation, and it goes right 1, down 1. So that would be right 1, down 1. Of what? Now here, we don't have any letters at all, like A, B, C. The triangles aren't named. So what we're going to do then is just put X, Y. That means it's just a coordinate X, Y. So if there are no letters or points given for the shape, we're just always going to put X, Y. So because it went right 1, down 1. And in problem 5, we're going to skip that right now. We're not going to do problem 5. So the vocab review for section 1 would be transformation, rigid motion, pre-image, image, and translation.